Problem number 1 is asking us to simplify the expression, and in this case we are adding the two polynomials. So when adding, you can basically ignore the parentheses and we're just going to combine like terms. So starting with my highest degree exponent, I have 7x to the fourth, and there are no other 7x to the fourth terms, or x to the fourth terms. Next highest degree is my x cubed term, and there are no other x cubed terms. Now I can combine my negative 9x and my positive 11x to make positive 2x. And lastly, I have my constant term, which is 14, so plus 14. All right, number 2, we are again simplifying the expression, but in this case we are subtracting. So to subtract, first thing we have to do is we have to distribute that negative to the second parentheses. So I have 18x to the fifth minus 4x cubed, and then I have minus 7x to the fourth plus x cubed minus 6x minus 11. So remember, when we distribute the negative, it basically switches the signs of everything in the second parentheses. Now we're going to combine like terms. So starting with my highest degree exponent, I have 18x to the fifth. And then I have my x to the fourth term, which is just negative 7x to the fourth. And then I have my x cubed terms. So negative 4 and positive 1 is negative 3x cubed. Then I have my minus 6x minus 11. All right, the next problem, again, we're subtracting, so we're going to distribute that negative. So I have 9x squared plus 7, and then minus 2x cubed plus 13. So again, combining like terms, starting with my highest degree, it's negative 2x cubed. Then I have my plus 9x squared. And then I have my 7 and 13, which is plus 20. Number 4, it says which of the following result in x squared minus 44. So one way you could do this, instead of multiplying these numbers out, we could remember that we can factor this. And when we factor this, we take the square root of x squared and the square root of 144, since these are both perfect squares, and we get x plus 12, x minus 12. So when we factor x squared minus 144, we get x plus 12, x minus 12, which means B is the correct option here. All right, number 5, what is the product? So we're going to distribute. So 8x times 5x is 40x squared. 8x times positive 7 is, 8 times 7 is 56x. All right, number 6, we're finding the area and the perimeter. In order to find the area, we multiply. So we have 2x plus 3 times x plus 1. And we're going to multiply here. So 2x times x is 2x squared. 2x times 1 is plus 2x. 3 times x is 3x. And 3 times 1 is positive 3. Now we can combine like terms. So we get 2x squared plus 5x plus 3. And then to find the perimeter, okay, we know that this is x plus 1 and this is 2x plus 3. So one way we could write this is, we know we have two x plus 1s and we have two 2x plus 3s. So we can add up all the sides this way. So first we need to distribute. So this is 2x plus 2, and then distribute here, plus 4x plus 6, and now we combine like terms. So 2x plus 4x is 6x, and then I have 2 and 6, which is 8. So this is the perimeter of the rectangle. All right, number 7, it says what is the product of the polynomial? So I'm going to do this one a different way. Instead of doing the box, I'm going to do the one where we stack it. And we're going to multiply. So 6 times negative 4 is negative 24. 6 times negative 5x is negative 30x. 6 times 3x is 18x squared. And now we're going to multiply out the x. So x times negative 4 is negative 4x. X times negative 5x is negative 5x squared. And then x times 3x squared is 3x cubed. Now we add straight down. So I have negative 24 here. Negative 30 and negative 4 is negative 34x. 18x squared minus 5x squared is 13x squared. And then I have a positive 3x cubed. All right, number 8, we're finding the area of the shaded region. So in order to do this, we need to find the area of the smaller shape, the area of the bigger shape, and then subtract. So for the smaller shape, we're going to multiply 2x minus 1 times 3x minus 1. Okay, and using distributive property here, 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Negative 1 times 3x is negative 3x, and then negative 1 times negative 1 is positive 1. Now we're going to combine like terms, my middle term, so I have 6x squared minus 5x plus 1. And now we're going to find the area of the bigger triangle, or bigger rectangle, sorry. So 2x plus 4 and 3x plus 6, and we're going to multiply it out. So 2x times 3x is 6x squared. 2x times 6 is 12x. 4 times 3x is 12x. And 4 times 6 is 24. All right, now we combine like terms in the middle. So I have 6x squared plus 24x plus 24. So now in order to find the area of the shaded region, we're going to subtract bigger minus a smaller. So 6x squared plus 24x plus 24 minus the smaller one. So 6x squared minus 5x plus 1. So first we distribute that negative. So the first parenthesis stays the same. 6x squared plus 24x plus 24 minus 6x squared plus 5x minus 1. And now we combine like terms. So starting with our x squared terms, well, 6x squared and negative 6x squared, they basically just cancel each other out. So now I can go straight to my x terms, 24 and 5, so that's 29x. And then I have my constant terms, 24 and negative 1, which is 23. All right, number 9. So first thing we need to do is expand. So 5x minus 11 times 5x minus 11. And now we can go ahead and multiply. So 5x times 5x is 25x squared. 5x times negative 11 is negative 55x. Negative 11 times 5 is negative 55x. And negative 11 times negative 11 is positive 121. Okay, now we can combine like terms. So 25x squared, 55 and 55 is negative 110x, and then plus 121. All right, on the next page here, so we're looking for the GCF. So another way to easily look for the GCF is we just have to look at the smallest number. So looking at 8, we have 1 and 8, 2 and 4. And then we can see that the largest my GCF can be is 8, but 8 doesn't go into 12 and 18. So now we should look at the next biggest number, which is 4. So 4 goes into 12 and 4 goes into 8, but 4 does not go into 18, so it can't be 4. So then 2 goes into 12, 2 goes into 8, and 2 goes into 18, which means my GCF is going to contain a 2. So my GCF is going to be positive since my leading term is positive. Next we look at our lowest degree exponent, which is just a plain old x. So my GCF would be 2x. All right, number 11, we're going to completely factor the polynomial. So first looking at my terms, 12, 120, and 252. So we know that the biggest my GCF could be is 12, but we'd have to check to see if 12 goes into 252. So if we do 252 divided by 12, we get 21, so that means my GCF is going to be 12, and then we look at the lowest degree exponent, which is x cubed. So to rewrite this, we have 12x cubed, and then we divide everything. So 12x to the 5th divided by 12x cubed is x squared. Negative 120 divided by 12 is negative 10, and then we have 1x left over. And then 252 divided by 12 is 21, so plus 21, and our x cubes cancel out. So since we have a quadratic left over, we can go ahead and use our box. So this is x squared minus 10x plus 21. We're multiplying to make 21, and we're adding to make negative 10. So since we're multiplying to make a positive number and adding to make negative, we know that our two signs have to be negative. So listing out my factors of 21, I have 1 and 21, 3 and 7. So those are my only factors, so that means it has to be 3 and 7. And we should double check that those multiply to make negative 21, they add to make negative 10, which they do. Okay, now we can get the outside. So looking at my top row, x squared and negative 3x, we can take out an x, and then we work backwards. X times x gives me x squared, x times negative 3 gives me negative 3x, and x times negative 7 gives me negative 7x. So my final answer, don't forget the GCF out in front, is 12x cubed times x minus 7 times x minus 3. All right, number 12, we're going to factor. So this is a quadratic. There is no GCF, so you go straight to the box. Okay, we're multiplying to make negative 27, adding to make positive 6. Since we're multiplying to make a negative, that means my signs have to be opposite signs. So listing out my factors of 27, 1 and 27, 3 and 9, and that's it. So of these, we can use 9 and 3 to get 6, and in order to get positive 6, it's 9 and negative 3. So now we can put that in the box. So this is 9x and negative 3x, and then we can get the outside. Top row, GCF is x, so this has to be x plus 9 and negative 3. So my factored polynomial is x minus 3 and x plus 9. All right, 13, another factoring problem. Again, there's no GCF here, so we go straight to the box. X squared plus 12x plus 32. Multiplying to make 32, adding to make 12, which means both my signs have to be positive. So listing out my factors of 32 is 1 and 32, 2 and 16, 4 and 8, 5 doesn't go in, 6, 7. So I think those are all the factors. The one that gets us 12 is 4 and 8. And then we GCF the top row. So x squared and 4x, we can take out an x. And then we work backwards. X times x is x squared. X times positive 4 is 4x. X times positive 8 is 8x. So my factored polynomial, x plus 4, x plus 8. All right, 14. So this one, when we have a binomial, we should check to see if both terms are perfect squares, and they are. So we can take the square root of 4x squared is 2x. Square root of 81 is 9. So this is difference of two squares, so we can write our answer as 2x plus 9 and 2x minus 9. So that's difference of two squares. All right, number 15, we're going to solve by factoring. So since one side already equals 0, we can go straight to the next step, which is checking for a GCF, and there is none. So now we go to our box. So 3x squared minus 7x minus 6. So I'm going to do my work over here off to the side. We're multiplying to make negative 18, since negative 6 times 3 is negative 18, and we're adding to make negative 7. Since we're multiplying to make a negative number, that tells me my signs, one has to be positive, the other has to be negative. So now I'm going to list out my factors of 18. 1 and 18, 2 and 9, and 3 and 6. So the pair that gets me 7 is going to be 9 and 7, and it's going to be positive 2 and negative 9. Alright, so now to get the outside, we GCF the top row. So 3x squared plus 2x, all they have in common is an x, and then we can work backwards. X times 3x gives me 3x squared. X times positive 2 gives me 2x. 3x times negative 3 will get me negative 9x. So now I have my factored polynomial. 3x plus 2 times x minus 3 equals 0. And then now we can use zero product property, and we set each factor equal to 0 and then solve. So I'm going to solve this one first since it's easy. So x equals 3 is one solution. This one we're going to subtract 2 first. So 3x is negative 2, and then divide by 3. All right, number 16. Okay, another solve by factoring. So first thing we need to do is get one side equal to 0, so we're going to add 16 to both sides. And none of those are like terms, so we can't combine them. So now we factor. First thing we do is we look for a GCF, which is going to be 4. So we have x squared plus 5x plus 4. Since we have a quadratic left over, we can use our box to factor. So x squared plus 5x plus 4. And we are multiplying to make 4, adding to make 5. So both positive. So there's my factors of 4, and the one that we're going to use to get 5 is 1 and 4. Alright, and then we GCF the top row. So x squared and 1x, we have x in common. So then this has to be x plus 1 plus 4. So now my factored polynomial is 4x plus 4, x plus 1 equals 0. And now we can use zero product property. So I know 4 can equal 0, so we're just going to set the ones that contain x equal to 0 and solve. So this is negative 4, since we would subtract 4, and this is x equals negative 1, since we would subtract 1 to solve for x. All right, last problem, number 17. What are the solutions to the equation? So this one we are not going to solve by factoring. We're going to solve by taking square roots, since we have a linear binomial squared. Since our linear binomial is already by itself, we can go straight to the square root step. And 64 is a perfect square. The square root of 64 is 8, so it's plus or minus 8. And now we split into 2, so k plus 2 equals 8, and k plus 2 equals negative 8. Now we solve. So in both cases, we're going to subtract 2. So my solutions are k equals 6, and the other solution is k equals negative 10.